All right, this last video, this is the one that's going to kind of carry with part three as well. I just wanted to make sure we had enough time due to the restrictions on the amount of time I get with this screencast. So the biggest last example we're going to do is when we're looking to solve a triangle, if you have the following information. So what I mean by solve the triangle is we need to find all of the angle measures and all of the side lengths. So let's kind of just get a picture here. We have triangle ABC. So A, B, C. Angle A is 110 degrees. B we don't know. We know that this is 18 inches. And little c we know is then 14 inches. So kind of get a visual to kind of see what happens. The nice thing about a visual in this case is that as soon as we see that we have an angle and a side length that are given that are across from each other, so in this case it's a side-side angle relationship, we know that then we can use log sine. So we're going to do sine of 110 over its respective side of 18 is equal to sine of B over B, both are unknown, is equal to sine of C over 14. So there's you plugging into the formula, and now we're kind of just going to pick and choose which one situation helps us find best. Well, since this is the given information, we're going to match up with side 1, or ratio 1 and ratio 3. So we're going to go ahead and find sine C first because it's the angle that's across from the given side that's missing. So sine of 110 over 18 is equal to sine of C over 14. And we cross multiply, so we get 14 sine of 110 is equal to 18 sine of C. To get sine of C by itself, because our goal is to isolate that angle, we need to divide by 18. Divide by 18. So we get sine of C is equal to 0.7309. And to find an angle, like we did on the last page, we're going to go sine inverse of 0.7309. And that's going to give me my angle C. So second sine, second 0.7309, and we get an angle measure of 47 degrees. So this angle measure here will be 47 degrees. So C, 47 degrees. I'm going to go ahead and put that in my picture up here. And now, since we know that angle A, B, and C have to equal 180, the measurement of angle B then has to take 180, we minus 110, and we minus our new given angle of 47. And then we get the measure of angle B then is equal to 23. So you found measure of angle C, which helps you find the measure of angle B. So then B is going to be 23 degrees. Now, if you give this to be 46.6 or 9, I'm not going to mark it wrong. They'll just obviously change the value. So I think in most cases when we solve these triangles, we want them to the nearest degree. Now that we have the given angle C, we can go back to our law of sines formula, and we can realize that, okay, now I've got B, so I can rewrite that as sine 23 over B. I'm plugging the value that we just found in for the angle, missing the respective side. And you could go sine of C and go sine of 47 over 14, or I like to compare back to the beginning, because that way if this happens to be wrong, I'm not going to also get A wrong. So we're going to compare this to sine of 110 over 18, and then we cross multiply again. So a lot of this situation is build your proportion, show me this setup. This is what the geometry is. I want to see the algebra now after that. So we get B sine of 110 is equal to 18 sine of 23. Divide by sine of 110. Divide by sine of 110. So we take 18 sine of 23 divided by sine of 110. And therefore B is then equal to 7.5 inches. And the last thing you want to do in solving these triangles, or really anything, when we're looking at these triangles, is to make sure that answers make sense. This is your largest angle, is 18 your largest side. And if this is your smallest angle, 7.5 is the smallest side, then we know we did things on the right track. So let's go ahead and check to see if our answers are correct. 7.48, 23 degrees, 47 degrees. Good. Now, so this is just a rounding thing. We got 7.5 or 48 down here, which is 7.5. Perfectly acceptable. So just to review a little bit, solving the triangle means we need to find all of the angle measures, all of the side lengths. Do you need to do this on every question? No. But this is your kind of level 3, your level 4, your proficient or advanced level, just to make sure that you're connecting the concepts together. We connected law of sines to help us find angle C, and then we connected that value to help us find B, which then connected another law of sines. Like on the previous example, here's your connection here is you use the law of cosines to get the 13, and then because of that situation, we were then able to go into law of sines to be able to find our answer. So those are those connections. Now, due to the time constraints on the last video, I didn't get a chance. I wanted to show you what happens if you need to find an angle in this law of cosines formula. Let's say we want to find this angle, and I give you the 3 sides. I want you to kind of treat it like it's an algebra question. So let's just say that these are the side lengths. Side length A, we'll say, is 8. So in the triangle, it looked like this. This was 8, this was 4, this was 10. And I'm asking to find angle Y. So because the Y is across from the 8 leads us. And then the 4 and the 10 would then just switch around. So kind of like you done before, we kind of want to find all of these values. So we find the 8 squared, which is 64. We find what this is equivalent to. We find what 2 times 4 times 10 is equivalent to. And we get 64 is equal to 116 minus 80 cosine of Y. And in this situation, I want you to kind of think of this as being 2 is equal to 4 minus 6x. You subtract the 4, so we get negative 2 is equal to negative 6x, and then we divide, and we get x is equal to 1/3. So treat this, solving this value right here, similar to what you've done with all in your equations. It's just that this is represented by your x. So we need to isolate this expression. So we're going to subtract the 116. So 64 minus the 116 is negative 52, which is equal to a negative 80 cosine of Y. Now we divide then to get the cosine by itself. Divide by negative 80. This is a negative 52, a negative 52. So we take negative 52 divided by negative 80, and we get a decimal of 0.65, which is equal to cosine of Y. Just like how you did in the last one where we got this decimal of sine of C equals this. We need to now do the inverse, but instead of using sine, we're going to go cosine inverse of 0.65. Giving us our value for Y. So therefore Y in this case would then be equal to 49.5 degrees. I would also accept 50. That would be your angle measure for this question. So that means that this angle Y is 49.5, which then tells you that this angle right here is going to have to be bigger than that because 10 is bigger than 8. It also tells you that the angle up top here then would have to be smaller than that due to the fact that 4 is smaller than 8. So I just want to make sure I've covered everything that's going to be on your next test, next class period. The biggest thing with your test is making sure that we follow through on the directions. The directions, if it says a ratio, I just want to know a fraction. But if I say find the value or find the missing angle, then we're actually performing the trigonometry idea. Your test consists of 3 standards: 8.2, 8.3, and 8.4. 8.4 is the law of sines and law of cosine standard. 8.3 is the trig, SOHCAHTOA part. And then 8.2 is going to be your trig ratio. So 8.2 kind of sets up for 8.3, but 8.2 is going to be, give me the ratio of sine of 6 or sine of m. What is the ratio based on the triangle? So please make sure, I hope this helped prepare. I hope the videos give you a nice tutorial. Please come prepared for your test. Again, the same expectations on your test is that you're not allowed to use any note cards, not allowed to use any notes. You will be allowed to use a calculator. I will make sure that there is a set of calculators for everyone in the room, all of the same calculators. You will not be allowed to use your Chromebook. All right, you only be allowed to use the calculators that are in the room. All right, so I hope this helps, and thank you.